Hi there, my name is Canturri. I am a PhD student in the VMed program and in the Mycoplasma Research Lab here at the University of Minnesota. And today I would like to talk to you about Mycoplasma high pneumonia diagnostics, especially its detection by PCR. And I would like to do that using a classic of Western movies. So in this presentation, we will see who is the good, who is the bad, and who is the ugly in Mycoplasma high pneumonia detection by PCR. But first, let's talk about mycoplasma. Mycoplasma high pneumonia is the causative agent of enzootic pneumonia, an important clinical disease in finishing pigs, and its main characteristics are summarized in these pictures. So going from left to right and increasing magnification, we see that the most obvious clinical signs are coughing and decreased performance. When we zoom in, we see that the typical microscopic lesion is a consolidation of the cranioventral lung lobes. And when we continue zooming in, we see that the hallmark histologic lesion is a multifocal bronchointerstitial pneumonia. In the left end, at the highest magnification using electron microscopy, we see that all this trouble is caused by these very tiny round bacteria that attach to the cilia, destroying them. So now that we know that mycoplasma is a problem, how do we diagnose it? The most important idea here is that unlike other bacterial pathogens, Mycoplasma high pneumonia is very fastidious to grow in bacterial culture. So culture is not routinely performed as a diagnostic tool. Because of that, the infection is determined by the presence of clinical signs, the detection of genetic material by PCR, and serology. So this impossibility to use bacterial culture is the butt of the movie, as PCR is the most practical tool that we have in our hands to determine the presence of mycoplasma in a sample. And even if PCR is a great diagnostic tool, it's always good to have in mind that it's just mere detection of genetic material. It does not give us any information about viability of the detected pathogen. And again, PCR is a greatly used diagnostic tool because it has high sensitivity and specificity, but sometimes we can be puzzled by an unexpected PCR result that we don't know how to interpret. And I can really tell what it's like to be puzzled by a PCR, as we recently had problems of interpretation with the detection of Mycoplasma high pneumonia in processing fluids, in which we detected the bacterium in a sample type that it's not coming from the respiratory tract. And after extensive investigation, our hypothesis is that it could be environmental contamination of the samples rather than true presence of viable mycoplasma. So we know that the origin of the detected genetic material is sometimes difficult to ascertain. And this is probably because DNA is very resistant to degradation after the pathogen is no longer viable or alive. Therefore, since Mycoplasma high pneumonia PCR targets DNA, it detects both viable and non-viable cells. That is mycoplasma that is alive and mycoplasma that is dead. So you see that Mycoplasma high pneumonia diagnostics are not always straightforward, and things can get a little bit ugly. So here we have the ugly of the movie, as results can be sometimes misleading and difficult to interpret. Again, one of the main pitfalls that PCR has is that it does not provide any information about the viability of the detected pathogen. So what can we do to improve diagnostics? I think that our current strategy to detect Mycoplasma high pneumonia in clinical samples is well described by this also classical Western picture. We just want to get it, dead or alive, no matter what. And PCR is a good assay to do that because it detects both viable and non-viable cells. But we have seen that this can be problematic in some scenarios. But what if we could change the meaning of this picture? What if we could change the meaning of this or? And what if we could say, we want to detect mycoplasma and differentiate between dead and alive? And I think determining viability is essential to improve our diagnostic capabilities, but we need a method that does not rely on culture. So in the lab, we have been working on developing and standardizing a new viability PCR that would only detect mycoplasma when it's alive. And we have used it in vitro with good results. So finally, we found the good of the movie, our viability PCR. This tool that we have developed has very high potential and will open a wide umbrella of possibilities to investigate many aspects of Mycoplasma high pneumonia infection that are currently unknown. So what's next? Our viability PCR can be applied to different scenarios in which knowing the viability of the genetic material is important, such as when monitoring the clearance of infection at the end of the elimination programs, when we have unexpected positive results, or in internal biosecurity protocol. And finally, I've highlighted the word etc. to emphasize that the applicability of this diagnostic tool is very high, and all of that is work in progress. And with that, I would like to wish you all a happy Research Day. And if you have any questions, my contact information is here. Thank you.